Okay, so in this problem, we're given a five-term non-decreasing sequence of positive integers, and each one ranging from 1 to 5. And we want to compute the probability that there's some three terms in that order that form an arithmetic progression. So we'll start by noting that there are two cases where an arithmetic progression can happen. We can have an increasing arithmetic progression. So 1, 2, 3, 2, 3, 4, 3, 4, 5, and 1, 3, 5 are all the possible ways this can happen. Or we can have a triplet of numbers. So 1, 1, 1, 2, 2, 2, etc. And so we're looking for cases where both of these happen. And note that since the sequence is of 5 terms, there can be cases where both of these happen simultaneously. For example, 1, 1, 1, 2, 3, or 1, 3, 3, 3, 5. And so since both of these cases can happen simultaneously, and they also cover most of the non-decreasing sequences, the best way to solve this problem is by complementary counting, because we can avoid the overcounting case, and we also have to count fewer. So we'll split this into cases by the number of distinct possible elements. So for the 5 case, the distribution has to be 1, 1, 1, 1, 1. So where we have one of each digit. And so the only possible sequence is 1, 2, 3, 4, 5. And this clearly contains 3 numbers that form an arithmetic progression. Just take any one of them. So the number of ways to choose a non-decreasing sequence that doesn't contain an arithmetic progression is 0. And now we'll consider the 4 case. For the 4 case, our distribution has to be 1, 1, 1, 2. And note that we're looking for either of these cases with a non-decreasing or with an increasing arithmetic sequence or just a triplet. And given the possible distributions, a triplet is guaranteed to not happen. So we only need to consider the case where we have an increasing arithmetic progression. And here it's easy to list out all the possible non-decreasing sequences of 4 distinct numbers. We have 2, 3, 4, 5, 1, 3, 4, 5, 1, 2, 4, 5, 1, 2, 3, 5, and 1, 2, 3, 4. And note that only one of these, 1, 2, 4, 5, does not contain an arithmetic progression. So this one has 2, 3, 4. This one has 3, 4, 5, 1, 2, 3, and 1, 2, 3. So we only need to consider this case. And then since we only have one possible sequence, we multiply by 4 because we need to consider which element has the duplicate. So in this case, we have 4. And now we'll consider the 3 case. For 3, we have 2 possible distributions, 1, 2, 2, and 1, 3, 3, or 1, 1, 3. And for this case, since we want to avoid either of these, we also want to avoid the triplet. So we don't consider this case because this one is guaranteed to have a triplet. So we only need to consider the 1, 2, 2 case. And for this one, we want to choose 3 numbers that don't form an arithmetic progression. There are 10 possible ways to choose 3 distinct numbers from 1 through 5, just by 5 choose 3, which is 10. And note that up here we have 4 possible arithmetic progressions. So that means the remaining 10 minus 6 of them, or 10 minus 4 of them, must be non-arithmetic progressions. So here we have 6 possible sequences. And note that the possible distributions are 1, 2, possible distributions are 1, 2, 2. So there are 3 ways to choose the element that only has one of them. So here we have 3 times 6, which is 18. So over here for the 3 case, we have 18 possible non-decreasing sequences that don't have an arithmetic progression in them. And note for the 2 case, the possible distributions are 1, 4, 3, 2. And in both of these cases, just by Pigeonhole's principle, we're guaranteed to have like one triplet. So neither of these cases will work. So the 2 case is 0. And for the 1 case where we only have one distinct number, obviously all 5 of them must be that number, and then we'll have a triplet. So this is 0 as well. So we note that in total, we have 22 sequences that don't contain an arithmetic progression. And so we simply need to subtract this number from the total of non-decreasing sequences. And to find the total number of non-decreasing sequences, we note that we have 5 elements, or 5 terms, and we have 4 possible elements. And then we could use the balls and sticks method. So to divide 5 terms into 5 groups, we need 4 dividers. So we have 4 dividers. And then to use balls and sticks, we simply choose 9 choose 2 or 9 choose 4 because there are 9 choose 4 ways to arrange these. So we get 9C4, and this is equal to 9 times 8 times 7 times 6 all over 24. And this is equal to 126. So now we get this is our total number of ways to form a 5-term non-decreasing sequence. And now since we counted 22 ways to not form an arithmetic progression, we simply need to subtract. So there are 104 ways to choose a non-decreasing sequence that contains an arithmetic progression. And dividing this by 126, we get this is equal to 52 over 63. And that's our answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.